What more can we learn about equivalent ratios? First, let's think a little deeper about the phrase equivalent ratios by looking at each word on its own. So the word equivalent, what exactly does that mean? Equivalent simply means the same amount or value. Like 2 plus 2 is equivalent to 4. But what about the word ratio? Do you remember what that means? We've been defining it as two amounts being compared, but we also know that ratio is a relationship between two amounts. So this ratio, 2 to 3, shows a relationship between an amount of 2 and an amount of 3. And so when we put the words together, equivalent ratios, we find that they are ratios with the same relationship. Let me explain. For example, the ratio 2 to 3 is equivalent to the ratio 6 to 9. How so? Take a look at these dots, 2 red and 3 blue. They illustrate a ratio of 2 red to every 3 blue. If we wanted to make an equivalent ratio, we could simply draw the same thing on the other side. 2 red and 3 blue on one side and 2 red and 3 blue on the other, making an equivalent ratio on both sides. 2 to 3 is the same amount as 2 to 3. But what if we added another group of 2 red and another group of 3 blue? And let's not stop there. Let's add yet another group of 2 red and another group of 3 blue. Now, even though one side says 2 to 3 and the other says 6 to 9, I see a group of 2 to 3 on one side and I see an equivalent group, 2 to 3 on the other side. And I see yet another group of 2 to 3 and yet another group of 2 red to 3 blue. Now looking at this, we see that there are 2 red and 3 blue on one side and 6 red and 9 blue on the other side. And so we know that 6 to 9 is 3 times as large as 2 to 3. But the kicker is this. Both of these are equivalent to each other. They have the same relationship. How so? Well, I see 2 to 3 on both sides. For every 2 red on the left, there are 3 blue. But on the right side as well, for every 2 red dots, I see 3 blue dots. Yes, there's 3 times as much. But we're not talking about having the same amount. We're talking about having the same relationship. And both sides have a 2 to 3 relationship. And because they both have the same relationship, we call them equivalent ratios. And what about our lesson from last time? We had this tape diagram showing a ratio of 2 incorrect to every 9 correct. And then we plugged in different values for each unit and found that we could also have 8 to 36. So are these two ratios equivalent? Do they have the same relationship? Of course, there is a 2 red units to 9 green units on one side, as well as 2 red units and 9 green units on the other side. Even though the amounts of the units are different, the relationship 2 to 9 remains the same, thus they're equivalent. Well, that's great and all, but what if we don't have tape diagrams and dots to visualize this? How can we tell if two ratios are equivalent? Let's look at these two ratios, 1 to 2 and 6 to 12. Well, if I take a look at the 1 to every 2 and the corresponding 6 to every 12, I could just think to myself, is the 6 to 12 a certain number of times larger than my first ratio? And of course, 1 6 times gives me 6. So that works for the first number in our ratios. But for these ratios to be equivalent, it must also work the same for the second number of the pairs. So does the 2 turn into a 12 by having it 6 times? Of course, 2 6 times is 12. And because both the 1 and the 2 are 6 times smaller than 6 to 12, we know that they are equivalent. They have the same relationship. 1 is just 6 times larger. So it is absolutely correct to say that these are equivalent even though they look completely different. Even though 6/12 looks so much larger, remember we're not talking about the quantity, only the relationship. Let's use dots to make sure that what we've done is correct. So I have 1 to 2 on one side and 6 to 12 on the other. I see a 1 to 2 relationship on both sides once. I see another 1 to 2 relationship, and yet another, and another, and a fifth time. And lastly, I see one more group of 1 to 2. When all is said and done, yes, there is 6 times as much on the right, but the relationship of 1 red to every 2 blue exists in both, so these two ratios are equivalent. Let's apply all this to a problem. Let's say that for every 7 students, 2 of them have overdue library books. So 2 out of 7 students have overdue library books. A girl named Jasmine pops up and says, 2 out of every 7 have overdue library books? Oh, then that means that in my class, there are 24 of us that have overdue library books. How did Jasmine figure that? To find out if Jasmine is correct, we can look at the first numbers in our pairs and see, are they equivalent? Can we go from 2 to 24? And of course we can. 24 is simply 12 times more of 2. For these to be equivalent ratios, we must do the same thing to the other side. So I need to have 7 12 times. And 7 12 times happens to be 84. Because 24 to 84 is simply 12 times larger than 2 to 7, these two ratios are equivalent, though they may look different. Now let's illustrate this with dots just to make sure. Here are my 2 students out of every 7 that have overdue library books. My overdue library book students are green in this case. Notice that I only drew 5 purple dots for the rest of the students. Why? Well, if the ratio says that 2 out of every 7 have overdue library books, then the out of 7 includes those 2. So for me to make 7 students, I need the 2 that have overdue library books and then 5 more that don't, making a total of 7 students. Okay, on the other side, Jasmine said that 24 students out of her class have overdue library books, so I draw them. Now, again, for this to work, we must see the same ratio in both, 2 out of every 7. So, if I include 5 dots for every 2, making groups of 7 all throughout this problem, then these two are equivalent, and sure enough, I can. I have one group of 7 with 2 students having overdue library books on the left, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 groups of 7 students on the right. 2 of each of those groups of 7 have overdue library books. By the way, how many students then does Jasmine have in her class total? Well, if we add up all these students, overdue library book people, and the rest, we see that there are 84 students. Take a look now at these ratios. Are they equivalent? Well, let's start with one number on one ratio and see how it relates to the first number of the second ratio. Well, to go from 6 to 42 is 7 times larger. And so, for the second number in my first ratio, how it relates to the second number of the second ratio, in this case, is 8. 11 8 times is 88. So do both of these ratios have the same relationship? Now, because both the first and second number of both ratios are not multiplied the same, these ratios are not equivalent. Though we could make them equivalent by changing a number, let's do that. If my 6 to 42 remains the same, and it's 7 times larger, then my 11 to another number must also be 7 times as much. So what is 11 7 times? 77. And now, because both the first and second number of both ratio pairs is multiplied by 7, these ratios are equivalent. They have the same relationship. Putting an equal sign tells everyone that these ratios are equivalent. Let's try these ratios. Are they equivalent? Well, how does the first number in the first ratio relate to the first number in the second ratio? 0 how many times equals 0? Well, the truth is it could be 1,000 or 2 or 75. 0 groups of anything is still going to be 0. Let's instead take a look at the second number in both ratios. How does the 5 relate to the 20? It is 4 times as much. And since equivalent ratios must have the same relationship, we must also have 4 times on the top. And what do you know? 0 4 times is also 0. So these ratios are equivalent. And again, let's not forget our equal sign to show that they are. Now, in a bag of mixed walnuts and cashews, the ratio of the number of walnuts to the number of cashews is 5 to 6. Let's find out the amount of walnuts in the bag if there are 54 cashews. Alright, let's put down what we know. walnuts to cashews is 5 to 6. And we know that cashews total is 54. What we don't know is the amount of walnuts, so we can put a question mark. So our ratios look like this. But lest we are looking at a bunch of numbers forgetting what they mean, let's make a table and put W for walnut and C for cashews. And now let's look at how the second number in the ratios, since they are the only pair that we have complete, relate to one another. How does 6 relate to 54? 54 is 9 times as large as 6. For these two ratios then to be equivalent, the relationship must also exist the same on the other side. So what is 5 times 9? 45. And so now we have 45 walnuts to every 54 cashews, which is equivalent to the ratio of 5 walnuts for every 6 cashews. Let's now use tape diagrams to visualize this. Here's my 5 walnut units and my 6 cashew units. Of course, we were also told that the cashew total was 54, and because we have 6 units, we can divide those 54 into 9 for each unit, making a total of 54. Now, because we know that each unit is worth 9, we can simply plug that in for our walnut units. And to find out our total number of walnuts, we can add up all those 9s or multiply 5 times 9, which gives us a total of 45. Okay, so what more have we learned about equivalent ratios? For one thing, we learned that even though ratios may look different and have different amounts, they can be and may be equivalent if they have the same relationship in both ratios. Like this, 2 to 3 is the same on both sides. We also learned that we can take one ratio and multiply it a certain number of times and come up with an equivalent ratio as long as we're multiplying the first and second number in the ratio the same amount of times. We also learned that ratios are not equivalent if both the first and second number have to be multiplied a different number of times. No, ratios are equivalent only if the relationship in both ratios is the same. We also visualized this with things like tape diagrams and dots, seeing how there might be 5 walnuts to every 6 cashews. And if we plug in whatever amount we want to into all of the units as long as they are the same, then we know we also have an equivalent ratio. So 5 to 6 is also equivalent to 45 to 54.